experiment, I'm going to try to make some copper sulphate using a technique that involves a base and an acid. Now, we tried to make copper sulphate by putting copper into the acid last time, and we noticed that the copper just didn't react. It sat there and did nothing. So we're going to try this strategy, and this is much, much more reliable. Now, I hope you'll remember that a base is a metal oxide or a metal hydroxide. Now, in this case, I'm going to use copper oxide, so it's a metal oxide and definitely a base. I'm going to add it to my sulfuric acid. So, there are various stages I'm going to do with this to try to make some nice copper sulphate crystals. And I want to make sure that I do it safely. So, I've got some sulfuric acid in my beaker, and I want to add some copper oxide to it. Now, the reaction is quite slow. So at the moment, it doesn't look like it's doing anything terribly much in there. But what I'm going to do is to heat it up a little bit in order to speed up the reaction. We know that higher temperatures help reactions go faster. So I'm going to use my Bunsen to warm this mixture. I want to be very careful to make sure that I don't boil the acid. Because if I boil the acid, I'm going to make some steam, which will have some acidic vapours in it, acidic fumes in it, and I might breathe them in, and that would be very unpleasant. I need to keep it warm, but not boiling. And I hope, as it slowly reacts, we'll start to see the colour of the liquid change, showing that the copper sulphate is forming. A glass rod here that I can use to help stir it up. Now I can see, looking down from the top, that this mixture is getting a very slight blue cast to it, so I'm confident that that is starting to react, but I'm going to leave it to settle a little bit so that you can see when that copper oxide residue that hasn't reacted yet settles to the bottom, you can see that we've got a really nice deep blue solution. See that this has formed a really lovely deep blue solution, and you might be able to see in the bottom there's still some black powder, some residue. I don't know if you can see that from this angle. There's some, can you see it? So you can see some black powder in the bottom, some residue of that copper oxide. Now I've done that deliberately. I deliberately put too much copper oxide in there because what I want is to be sure that all my sulfuric acid has reacted. So by using deliberately too much of the copper oxide, it means that I can be sure when I see copper oxides left over that there can't be any more sulfuric acid left for it to react with, or it would have reacted. So I know that in here, in the liquid, it is literally just copper sulphate and water, no sulfuric acid remaining. So I know it's safe for me to go on to the next stage of my experiment. Now, this beaker's possibly a little bit warm for me to touch. I think I just picked it up, but I'm going to show you how to use this. This is a paper tong, and these are quite handy if you think something's too hot to touch, because you can use it to grip around the beaker, and it gives you a nice tab to hold, and you've got a bit more control than trying to use those silly scissor tongs. I'm now going to try to filter this, because I want to filter out any excess copper oxide that's in there. Now the solution that should come through there should be very nice pure copper sulphate solution, and all my residue of copper oxide will be stuck in the filter paper. I think we'll come back in a moment when that's finished filtering and have a look at it again. This has been left filtering for a little while now, and you can see the solution that's come through the bottom is this really lovely deep blue copper sulphate solution. So I'm just going to remove the funnel, because what I need to do next is to try to concentrate this solution. What I want to do is to grow some crystals from it, but at the moment it's going to take a long time for crystals to grow from that, because there's an awful lot of water in there that's still got to evaporate. So I'm going to force that process a little bit myself by using an evaporating dish. I'm pouring my solution into the evaporating dish, and you can really see the strong blue colour in there. It's absolutely lovely. Now I've got a choice. I could heat that really vigorously for quite some time and boil off most of the water, and I'd be left with lots of very tiny little copper sulfate crystals that would actually look a little bit disappointing. But what I want to do is to grow some larger crystals. So I'm going to heat it just to remove some of the water and let the crystals grow over a period of time. So I'm putting my evaporating dish up on the tripod and ready to heat it. Okay. Now, I've got a glass rod here, because as this boils and the water evaporates, I want to test whether I've made a saturated solution in there. And the way to test is by dipping in a glass rod and seeing if crystals start to form on the end of the glass rod. If that happens, then I know it's ready, and it means I can stop heating and leave this whole mixture to cool and crystallise. So we're going to leave this for a little while, and we can come back again at the point where it's saturated. We've got to the point now where it's at saturation, and I've done my glass rod test, so I don't know if you want to zoom in, and you can see it genuinely has formed little crystals on the end of the glass rod. So I know that it's ready to leave now and cool, and it should crystallise and start to grow some really nice big crystals. So we're going to put that somewhere safe to cool down and crystallise, and we'll come back again in a couple of days and see if we've grown any crystals. We're a few days later now from when I did my experiment, and some lovely big crystals have grown in that saturated solution. I don't know if you can see them there. What I want to do now is not to let it dry out completely, but I do want to salvage those crystals. So what I've got in there are really nice, what we call hydrated crystals. So I'm going to filter them. There we are. So that I can collect the crystals that I've made. And pop back in a minute when all that liquid has drained through and we can see the crystals collected in the top. The liquid is all drained away, and if you look in the top of the funnel you can see these lovely big crystals. So what I want to do now to make sure they're properly dry is just tip them out of that funnel, and I'm going to pat them dry with my tissue paper here. There's one. I've got some nice dry crystals of copper sulfate, and I have to make sure I wash my hands now because copper sulfate isn't very good for you. Okay, I've got some lovely hydrated dry crystals. So the hydration part refers to the fact there's water of crystallization stuck inside those crystals, and that's what's giving them that really lovely blue colour. The crystals themselves are actually dry on the outside, but there are just water molecules stuck within the crystal structure, and that's what we mean by a hydrated crystal. So this is now a dry but hydrated crystal.